we have on our Nikons, Kirk. Well, you know this. You've used it. I haven't. Is the time lapse, and I think it'd be great. Have you shot any time lapses of the stars yet with yours?
Oh yeah, did you see at the beginning of the Colorado video? I have a time lapse of the stars going around the beginning.
Oh, that's
That's
right. You did.
that's what that is. Yeah, yeah. And I've done Startrails and different time lapses. It's an excellent feature. It's so easy. You just push a button, you let it zip away for about an hour and a half or 2 hours, depending on the setting, and I'm super happy with it. I should do it more. It's just time is of the essence.
Yeah, yeah. So I guess there's a guy in the chat, Peter Wacker. He says he lives at the very southern point of Australia. So Peter, if you have a camera, we'd love to see some time lapse because anybody that's down there, we'd like to get as many submissions of these stars that we can get. Because I mean, even though I would think that Steve would probably be pretty honest about what he's doing. There's always going to be somebody to say, oh yeah, he's just faking or whatever. So if we get multiple sources, people doing this, taking these shots, I mean, it's going to tell us one way or the other. And even if it was true, even if there was a point where that proved conclusively that that the stars were rotating around Sigma Octantis, that does not invalidate the flat Earth in any way, shape, or form, because as I said before, we're dealing with two different phenomena. We're talking about the lay of the land, so to speak, which every indication, every measurement is telling us that it's flat. And even if you think that those are woefully lacking, the motion of the globe has been debunked a million ways, and still to this day we have no instrumentation that actually shows us in motion. That they've ever been able to detect any motion. And in fact, I think it was Einstein that said that he was convinced that optically there is no way to actually measure any movement of the Earth. And I think he's not the only person, even if he was a crazy fuzzy-haired crackpot, he wasn't the only person that realized that. But we're also talking about a century ago, nearly a century ago, and before that. And now here we are in the quote-unquote space age. We certainly should have that instrumentation that could measure that. So, anyway.
Hey Bob, if I may too, the stars rotating around Polaris, I think, is an excellent way just to spark people's interest in the fact that it never changes and that the stars always rotate around that star, and there's something to that. And it would be very difficult if you explained to them the position of the Earth, in winter versus summer, and the fact that those stars never change throughout the year or over time, and that's very interesting, and it could also lead to somebody investigating the flat Earth.
Right. Well, and of course the standard answer to that, Kirk, is oh, but they are changing from season to season, and yes, that is true to a certain degree, but nowhere near to the degree that they should be changing. When you get a complete flip of orientation of the Earth. And you're right. How can we be bolting through? And it's not just, as we have already determined, it is not just the sun that's whipping through space at 500,000 miles an hour. The Earth is tagging right along with it, as are supposedly all the other planets. And again, when you kind of think about that, at over 500,000 miles an hour, rifling through space, it is impossible. Absolutely impossible that we would never have any change of orientation, especially in Polaris, right? Of course, the answer to that, the rebuttal, is going to be, well, yeah, but because we're dealing with such unbelievably astronomical distances that, we could travel for years and not even measure a fraction of a degree difference, which, again, also does not stand up to scrutiny. It's just nonsense. Not only does it not make any common sense, but I'm sure if anybody had was able to do the math on that, and that's assuming we could figure out all the different directions that we're going, it would probably mathematically prove out that that would be impossible as well. I think John the Morgile on our hangout a couple days ago was saying that he's trying to determine all the different directions that the galaxy is going, in the Milky Way, and going around, what, Sagittarius A? Is that what we're going around? Anyway, all the different directions, and he said that that kind of information is very difficult to find, which, you have to wonder why. And John is a very capable researcher. I haven't looked into it myself. I'm just going by what he said, but it defies all common sense. And I don't believe for one second that just because that these distances are so astronomically far out there, that's the reason that we're not seeing any general parallax shift or change in orientation.
Right,
And that just doesn't fly.
And it's not a fact. You can't say, oh, you're not detecting any parallax because they're so far away. That's not a fact. You're not giving me any proof or evidence. That's just, you just want me to believe that because you're saying these stars are so far away. Every star you see in that sky is part of a different galaxy. They have their own orbits, trajectories. You can't tell me we're spinning around and we're seeing the exact, the North Star in the exact same location year after year after year, and every star relative to the North Star in the exact position year after year. I mean, it almost smacks you in the face of being obvious. They don't change. I mean, these stars, if you believe NASA, are billions and trillions of miles away. Not only that, they're also all moving in their own orbital paths, and in their galaxies are also moving it in different directions. So you want me to believe something, but don't tell me it's a fact just because you're saying something's billions of miles away. That's not science.
Exactly. And of course, the way that they're actually arriving at these distances is precarious at best. They're going a whole lot. They're doing a whole lot of assumptions, when they start calculating the distance to the sun. And it's just like when Eratosthenes was planning his sticks. The whole idea back then was he had to be making the assumption that we were on a ball Earth in order to even apply that Pythagorean math, right? Because as TJ showed, when Jaron and Reg Reddick were going back and forth in their big, hot, heavy debate, Reg Reddick came out with a video saying, yeah, is Jaronism flat wrong? And so he does this little experiment between him and some person in California. I guess he's in Florida, and some person in California. And they did all the angles and everything, but they had to incorporate in, what is it, a 0.8 degree curvature. And when you do that, then all of a sudden the moon appears at its 250,000 miles roughly away. But you have to factor that in. If you don't factor in that curvature of the Earth, then the Pythagorean equations come back and show the moon at about 3,300 miles up. And ironically, if you were to use that exact same methodology for the sun, then it's going to show the sun also at either 3,300 miles up if you use the flat Earth geometry, or it's going to show the sun at about 250,000 miles up if you use the Pythagorean math. So,
Yeah, it's insane.
Sure, throw your math at us, and again, you're making a lot of assumptions in the first place, to come out with this geodetic math. Essentially, it's just like the same way geodesy works. Chris Van Meter and a lot of other planar surveyors are talking about, he told us how it's done, and anything that beyond that the geoid supporters are saying is a mathematical construct underlying that. It's simply math. It's nothing that they have ever measured, ever. They're just simply putting an underlying mathematical assumption or model underneath it and saying that, well, okay, so here's the curvature of the Earth, but you still can't measure it. So, yeah.
Yeah, and it's just like we were discovering recently, the whole, we were nitpicking our brains about the curvature and this and that. It's, you can see how easily different numbers and mathematical ratios can be used to describe completely different things. So it's no wonder that NASA's been able to pull the covers over our heads for this many years, because, like I said, you can describe something with mathematics, but that doesn't mean it's reality. It can be describing 4 different realities with the same mathematics. It's how you actually arrive at those numbers, which can only be through observation, testing, and reproduction. So
yeah, and the observation, of course, being the big thing. If you don't have the empirical evidence, then your math means nothing. You're creating a mathematical fantasy if you don't have something to rely on. And again, yes, the math can prove a lot of things, but then the math can also prove a lot of things that are complete hypothetical fabrications as well. They tell us mathematically we should be able to go backwards in time just as easy as you go through it forwards, right? Well, mathematically it works out, but when have you ever seen that happen? Well, you don't. So that's just one of those examples that you can use that show that. But yeah, when I look at this, the more I look at this and think about that this is truly what they would be saying, how the planets propagate in the sun through space, and I'm watching this cluster F. It's
Yeah. Whoa! Watch out.
yeah, a little hard to buy.